Here today, I'm delighted to make a presentation on, actually I'm not here to talk about blimps, I'm here to talk about zeppelins. Airship Ventures is a company that's located out in San Francisco, and we operate the only Zeppelin airship in the United States. It's currently the largest passenger airship in the world by about 6 inches. And just recently, we were the largest airship in the world. About 4 weeks ago, the LIMB had its first flight, and it's bigger than we are by about 50 inches. So we're now the second biggest airship in the world. Which says that airships have come down in the world quite a lot in the last 50 years when Zeppelins were commonplace and when they were 800 feet long. But anyway, this current decade is being called the new airship renaissance. And it is really seen all across the United States and even all across the world that there is an entirely new interest in lighter than air travel with airships, both the manned and unmanned varieties of lighter than air vehicles, for a couple of reasons. And we're going to go into this a bit, but the two big things I want you to take away with you about Zeppelins, blimps, airships, and aerostats, their tethered cousins, is that they're extremely efficient, since almost the lift of the airship, or staying in the air part, is provided by a helium. So the engines don't have to do any work to lift the airship up off the ground. They're simply there for propulsion. So airships, for that reason, are extremely efficient vehicles, and they can stay aloft for very, very long periods of time because they burn very little fuel. So I want to introduce you to our Zeppelin. It's called the Zeppelin NT07. The Zeppelin means, it's called the Zeppelin for two reasons. First of all, it was built by the Zeppelin Corporation in Friedrichshafen, Germany, which is the successor to the original Zeppelin company that was founded in the 1800s by Count von Zeppelin. Count von Zeppelin, by the way, got his inspiration for designing his powered balloon by coming to the United States. He was an observer in the U.S. Civil War and saw observation balloons being used by the Union Army, though actually he was up in Wisconsin for some reason. But that was where he got his original inspiration, was seeing observation balloons in the U.S. Civil War. The regular Zeppelin company was, let's say, put into storage at the beginning of World War II, but they put their funds into a trust fund, and it kind of sat there and gathered interest for the next 50 years until they decided to restart the production line in 1998. They started designing a brand new airship, and they called it Zeppelin NT, Zeppelin New Technology, and this is the result. So it still has a rigid frame, but now the frame, instead of being on the outside of the airship, is on the inside. And it's called it 07 because that was the original size of the envelope. It was 7,000 cubic meters. Ours got a bit of a stretch. The reason we're the biggest airship because ours is 8,000 cubic meters. We have an extra frame in ours. Makes it a bit longer. So in size, it's big. I mean, it's 246 feet long, 75 meters, 64 feet across the fins, it's 19.5 meters, and 17 meters tall, 57 feet from the bottom of the nose wheel to the top of the fin. So by any measure, it's a big ship. We're 15 feet longer than a 747-400. So at our maximum weight, if you could take all the helium out of the airship and put it on a scale, it will weigh 17,725 pounds, which is another way of saying that's the amount of mass we have. And our useful load is 4,299 pounds. That's fuel, oil, passengers, and equipment, which is considerable. That's a good 2 tons of lift that we can pick up with this airship. You'll notice one very unusual, if you've seen blimps before, you'll notice that two very unusual things about our airship. First of all, our engines, instead of being mounted on the gondola, down there where the people are mounted up here on the side. And they're mounted on this rigid internal frame that's underneath that envelope. There's a carbon fiber structure that kind of looks like an upside down bridge. I'm going to show you a picture of it in a second. But our engines are mounted up on the side of the envelope. The second bit you'll notice is we have a tail engine, just like a helicopter does. We have a tail rotor. It's actually two propellers connected to a single engine through a gearbox. We have one propeller sitting sideways, and we have one propeller that goes up and down. That gives us true vertical takeoff capability because the airship can maneuver with these vectoring engines. I'll show you the vectoring here in a second. There are three Iowa 360 pretty standard aviation Lycoming engines. Fuel injected, they're exactly the same engine. I used to own a Cessna Cardinal, and it's exactly the same engine that was in my Cessna Cardinal. Our max speed is about 65 knots. Our regular cruise speed is right around 40. So this is the vectoring part. You will recognize this, James, because just like a V-22, or like the Sky Eye, the Bell tilt rotor, Eagle Eye tilt rotor, ours is also a tilt rotor. So our side engines can tilt up actually 120 degrees. They can go 30 degrees backwards. And our tail engine tilts down to become the elevator for the airship. So when the airship's at zero airspeed, that aft power plant has got one propeller pointing up and down that's pushing the tail of the airship up and down, and then a second propeller that's pushing the airship right and left. If you think of a regular blimp, you've seen a Goodyear blimp, when they come into land, they kind of land like an albatross does. You've seen the pictures of albatross landing. It's not a very elegant affair. For blimps, it's not a very elegant affair either. And that's because below 10 knots, about 10 miles an hour, they don't have enough air blowing over their fins to control their airship anymore. So in other words, they become a free balloon. They go completely out of control once their forward airspeed drops below 10 knots. So what they do is they fly into the ground at a speed greater than 10 knots while they still have control, and then have the crew come out, about 10 guys, 10 to 20 guys come out, grab a bunch of ropes and wrestle this airship to a stop, which is, as I said, not a very elegant process. Our airship, on the other hand, comes to a complete stop 50 feet off the ground, all three engines pointed up, both tail engine pointed down, front engines pointed up. Comes to a complete stop because we have this aft tail rotor. We have complete control over the airship at zero airspeed here, and we make all of our takeoffs and landings are vertical. The nice thing about this is that instead of having 10 to 20 guys catching the airship every time we do a landing, we only need 3. Those 3 guys, there's one guy holding the nose, and there are 2 guys loading valves. So we can do a complete passenger turnaround with only 3 guys, which for an airship is absolutely amazing. It wasn't unusual for some of the bigger airships back in the 30s to require a 100-man ground crew, which is kind of hard when you go, I want to go somewhere in my airship, and then I got to ship 100 guys ahead to go catch the airship on the other side. So this is what she looks like in her takeoff configuration. You notice that the forward engines are tilted up, and the aft, if you can see that okay, and the aft engine is tilted down. So to give us control. When level flight, that rear engine comes up, the front engines go down, and everything's pointed in the forward direction. This is our internal frame. This is what it looks like if you took the skin off the outside of the airship. Keep in mind, structural engineer guys, you're going to think this is all backwards. There's nothing holding up this airship from the bottom, and that's because that's not how airships work. The helium is holding everything up, and all of the structure of the airship is suspended down from the helium. So all of our structures go down. None of it goes up. There's nothing holding the gondola up. Everything is suspended down. A bit like a helicopter in that regard. Everything's suspended from the rotor head. In our case, everything is suspended from our buoyancy, from our helium that's up in our bags. If we take the helium out of the airship, we actually have to support the frame. Yes, sir. Do you have a question? Oh. Yeah.
Where is the helium in all of this? If everything's suspended above, have you got
it's in this big bag.
So it's all just uniformly throughout that one cell?
We just saw one helium cell, yes. We have so the secret of how airships, and ours is called a pressure airship. That's because this envelope is very slightly pressurized. It's at 0.005 psi. 0.05 psi, excuse me. So it's just barely got just a very slight positive pressure. But we have to account for things because when we take off, of course, as we climb up through the sky, The air pressure on the outside of the airship gets less as we ascend, because the air pressure gets less dense as you climb away from the Earth. And that means the helium wants to expand. So we have to account for that expansion. So what we have in this airship are, inside are two smaller balloons we call ballonets. They're down in the bottom of the airship. You can kind of see the valve. That's another picture, you'll see the valves. But there are two giant airbags in the bottom of the airship that on the ground are filled with air. And as we climb, the helium expands and pushes the air out of the ballonets. And we get to the point where those ballonets are empty, we say we're at our ballonnet ceiling and we can't climb anymore without letting helium out of the airship. You got a question?
Are those struts inside built of aluminum or carbon fiber?
They are carbon fiber in the middle with aluminum ends. Much easier to weld on the aluminum, so the ends are all aluminum, the middle parts are all carbon fiber. And one that's the size of that table you're sitting at weighs about 10 pounds. It's amazingly light. One person can pick it up with one. These long struts, so the long parts are carbon fiber, and the end piece on the ends are aluminum, the bits where they join together. And you also notice the cables, and we're actually the structural part of the airship are the cables. The cables are the actual structural members. They carry all the loads. In the middle is what we call the dog bone, which is where the engine's attached to. It's a box spar made out of carbon fiber, and inside that box spar are our fuel tanks. So a handy place to keep those. This is the gondola. Gondola seats 14 people, 2 pilots and 12 passengers. We also have a bathroom, which one of our British pilots christened the loo with the view, because it has a window in it, so you don't have anything while you're visiting the bathroom. When you're on long patrol flights, believe me, having a bathroom is really nice. I've been in this airship for 8 hours at a time. It's nice having it. We don't have the galley. That was an option that the Zeppelin company put into the marketing brochure and didn't actually deliver in any of the airships. So we're still waiting on the galley. We haven't finished that one yet. We have 2 doors, one in the front, one in the back, and they're on either side of the airship. Anyone want to guess why we have 1 door on each side? Yeah, in case we fall over. Yep. So this is a little hard to read, but airships have a long and proud history of patrol over the ocean, primarily with the Navy, using large blimps to scout for submarines in World War II. And it is said that not a single ship was lost while being escorted by a blimp. The blimps protected over 89,000 ships. This is kind of my commercial for the utility of airships. This picture was actually taken right where all the other pictures you will see of the airship were taken at Moffett Field in California, where the airship lives today. That's why we're at Moffett Field. It's still got 3 remaining airship hangars, so we have 3 places to park our airship. So why airships? Why are they coming back? Why is everybody talking about airships? And it's not just me. I mean, we have Airship Ventures, you've got us guys, you've got, of course, got the Goodyear blimps and the DirecTV blimps and the light ships, the Snoopy and so on. But you probably saw in the news that Northrop Grumman has just launched the LIN-V, which is a 300-foot-long triple-load airship, a hybrid air vehicle, one that gets more of its lift out of forward motion and wings than it does out of its helium. It only gets 60% of its lift from helium and 40% of its lift from its shape. We get 95% of our lift from our helium and 5% of our lift from our shape. Or from the engines. So, and then Lockheed Martin has got 3 airships under construction right now. They've got their SkyTug, which is a commercial venture, a commercial airship. The HAA, High Altitude Airship, which is a project to put an airship that's supposed to stay, I think, for 6 weeks in the stratosphere at 60,000 feet. And then they've got ISIS, the Integrated Sensory Structure, a DARPA program to create an airship where the envelope is a giant radar antenna. It's kind of a cool concept. So the structure and the antenna is the envelope of the airship. So the pilot can fly for very long periods of time. The airships are very, very stable. If you got to ride on our airship, you notice it feels way more like a boat when it's in the air than it does like a plane. It kind of rocks with the air currents, and it's floating in the air, so it feels much more like a boat than it does like an airplane. We have a very large payload capacity. We're extremely environmentally friendly. I'll go into that in detail in a bit. But we have we make very little noise. We have very little vibration. We can fly at low speeds. Airships are extremely robust and survivable and tough. Believe it or not, you're basically flying a giant beach ball through the sky, and it's very hard to damage a beach ball, because if we hit anything, we're just going to bounce off. So it's actually, they're very, very robust systems, and that's been proven over and over again. I'll give you some details. And then we can carry a large variety of sensors, and we're a good place to put your sensors. If you're somebody who makes sensors, and you put them on an airplane or a helicopter, you go, oh my God, the vibration, you can't believe, and I'm trying to keep this thing stable, and I'm trying to point at something on the ground. And another example is we don't bank when we turn completely flat. The airship just has a rudder, it doesn't have any ailerons, so it does not roll into a turn like an airplane does, it turns flat. So the sensor remains on the target as you're making your turn. So, safety record. So this is one that people just don't believe me when I say this. And like, I'm going to stand here and pound on the table a little bit and let you know the truth. Because we've suffered from, our public relation problems, and they all start with the letter H. Airships have the best safety record of any flying vehicle there is. We have a much better record than balloons, helicopters, airliners, small planes, you name it, if it flies. The safest thing you can be in the air is an airship. I went and actually looked up all of the accident statistics. I've looked at every airship accident since back in the 30s. There have been exactly 2 airship fatalities, not 2 incidents, but 2 people killed in the last 50 years. Since 1962, there have been 2 airship fatalities. Airships are flying, there are currently 48 airships flying in the United States. And like us, almost all of them fly every single day. We fly 5 days a week, 8 hours a day, 11 months out of the year. So we're not sitting on our butts, we're flying every single day, and that's the accident record of airships. And we want to talk about helicopters kill over 1,000 people a year, much less. Yeah. But much less, half a century. So the last time a passenger was killed on an airship was 1937 in England. That is the last time a passenger was killed on an airship, was 1937. So, and of course the big reason for that also starts with an H, and that's helium. And that's because today, instead of putting hydrogen on our airships, every airship, and the FAA gentleman who's here will tell you, it says right in the rules, all airships will use helium as a lifting gas, there are no exceptions, don't even ask. So, that's actually become a problem lately because you may or may not have heard there is an international helium shortage going on right now. And I can tell you our personal experience, and I thought it was bad when I explained this a month ago when I said, okay, 18 months ago, helium was $30 a bottle. The big bottle that you see, the welder supply size bottle of helium, it's about 3 cubic meters, was $30. A month ago, that bottle was $130. We were paying $130 a bottle for helium just a month ago. Last week, we paid $200 for a bottle of helium. I am not kidding. The price of helium has skyrocketed.
What's the cause of the shortage?
Well, there were several of them. First of all, there are only 2 helium plants in the United States. One's in Amarillo, the other's in Kansas. The Kansas one had an accident and was down because it was broken, and then the Amarillo one had not been overhauled in 40 years, so it was down for overhaul. So both helium plants in the U.S. closed down. There's a plant in Canada, I believe, and a plant in Qatar. The one in Qatar is not online yet, it's just been built. Where do you get helium is the question. If helium gets into the atmosphere, it leaks away into space almost immediately. It rises to the top of the atmosphere and it goes away into space. So guess where we find all the helium in the world today? Anybody know? You get it out of natural gas wells. It's a decayed product of radioisotopes that live in that are down in the Earth's crust. Another name for a helium atom is an alpha particle. You've heard of alpha radiation, ghost radiation. Those are helium nuclei. So anywhere where you have radioactive decay, you get helium collecting. So helium collects underground in natural gas deposits, and it's a natural byproduct of drilling for natural gas, which is great because there's natural gas all over the place, even here in Fort Worth. The problem is that it takes a $500 million extraction plant to get the helium out of the natural gas. And they've only built 2 of those. And there's just not an economic case up until now. Now that it's $200 a gallon, a bottle, they'll start they'll start doing more. Actually, a couple things besides the plants going offline, the big user of helium in the United States is MRI machines. MRI machines sit in a liquid helium bath, and I was told, I have been able to verify this, there's 1,700 liters of liquid helium in every MRI machine, which would be an enormous amount of helium. So that's the big, and it's very hard for us to say, we need to put helium in our airship, can you please not put helium in your MRI machine? We're going to lose that case every time. I did have a nice conversation with the director of the National Helium Reserve in Amarillo, Texas. There's a giant salt mine with 7 billion cubic feet of helium in it. 70 billion, some large number. It's got B's in it. Anyway, they're trying to help us. So let's talk about sensors. And the big thing, the reason I like talking to UAV people is one of the biggest, okay, let me kind of explain the business model we have for our airship. Our airship does three things. We do passengers. We're the only passenger carrying airship in the United States. We're the only people in the U.S. you can go buy a ticket and fly on our airship. We're very proud of that. We do advertising, as you probably guessed. That's putting people's logos on the side of the airship. We are not owned by the people who put their names on our airship. We merely rent out the side as any other good billboard would. Just our billboard flies and carries passengers. But we act as a flying billboard. And we do what we call special missions, which is actually everything else that's not any of that. But a big part of our revenue comes from acting as a surrogate UAV. So what we do with our airship is we take UAV sensors and UAV components and we fly it for people who are developing UAVs who can't get flight time because there are only 3 or 4 places, or wherever number of places are in the U.S. you can fly your UAV legally. So we've been flying UAV components and UAV sensors and UAV systems on the airship, both as an engineering test model to do proof of concept and to do risk reduction for UAV designers. We have been taking UAV systems where they can't go by themselves, like downtown Los Angeles and over the San Francisco Bay, where you cannot legally fly a UAV. So we can, over Monterey Bay, we can take sensors places where they can't go because we're a fully FAA certified airship, so we can get clearance to fly anywhere an airplane can fly. And we're crewed and we're manned. And the other bit is that we have this huge, as we mentioned, that huge gondola. We have 14 seats. In physical space, we're almost the exact size as a G3, Gulfstream 3 executive jet. We have the same number of seats and we have the same cabin size and shape as a G3.
We don't have a room in the bathroom.
We have much bigger windows and a much better bathroom. And it's much more comfortable. Flight, of course, they go a lot faster and burn a lot more. So we've been flying sensors for people. So I'm going to tell you now about some of the sensors we have been flying on the system. I just finished testing or qualifying the FLIR 230 HD Star Sapphire. We have, by the way, 2 built-in camera platforms. We've got one on the nose of the airship, right in front. On the airship. There we go. Right on the nose of the airship is a camera platform that we normally, when we do sporting events, we carry a big Westcam 14-inch ball on that front camera platform. We've also got an aft camera platform that actually extends up to the bottom of the airship, which is this one you see here in this picture. This is our aft camera platform. We call it also the NADAR platform because it points straight down to the ground. And we generally put downward pointing sensors on that aft platform. The aft platform is rated for 400 pounds and the forward platform is rated for 320 pounds, thereabouts. So they're both pretty sturdy, and we can carry fairly large, substantial payloads. We can carry 2 big sensor balls. Where we've been carrying a FLIR. This FLIR actually doesn't weigh much at all, but it has a color HD camera, an infrared camera, a low light camera, a laser rangefinder, and a laser illuminator. Makes it a very useful device. We've flown that offshore in maritime patrol modes where we look for smugglers coming in off the ocean. It's also been used, we've been using it as we've been doing wildlife surveys for some people who've been hunting for large wildlife. We had one person call us up and wanted to rent the airship and the FLIR. And he said he was looking for this large mammal up near Seattle. You guys catch on fast. Very good. Very good, yes. So So we made up a little patch with a Bigfoot on it to go for that mission. But yeah, we had somebody actually rent us to go look for Bigfoot. One of the recent missions that we were very proud of is we got hired by NASA and the SETI Institute, the Search for Extraterrestrial Intelligence. There was a large meteor that fell over Northern California and landed in, believe it or not, the Sutter's Mills. Sutter's Mill is the site of the California Gold Rush. That's where gold was found in 1849. That's why the football team is called the 49ers today. Meteorite landed right in the middle of the gold fields out in Northern California. So we took the airship a week later with a super high resolution camera and flew at about 800 feet and searched for 3-inch and smaller bits and pieces of this meteorite. It went to about 10,000 feet and it exploded and shattered into thousands of pieces and went all over the place. So we, according to the scientists, we found about 10 fragments using the airship. That was a very cool mission. We had a lot of fun doing that. We've been flying, we've worked with Ray Marine, we've been flying some of their radar units. These are marine radars, and mostly for tracking boats. And we've been flying them offshore, using them to do offshore. We can use them for navigation, which is kind of cool, because you can navigate in very poor weather conditions using the radar as a navigation system. You can detect boats, of course, and it also operates on weather boats. We can use it as a weather radar, except it's 360 degrees. It's mounted on the bottom of the ocean. This device that you see in the picture is an Optec 3D LiDAR. LiDAR is my favorite sensor, because I've been involved with them heavily for a number of years. We use them a lot on unmanned ground vehicles, and 3D LiDARs paint a 3D image of the ground. So as we fly over the ground, we project this cone of laser light onto the ground, and it measures the time that it takes the laser pulses to go from the airship to the ground and back again. So we create a centimeter level quality 3D map of the terrain. You can do some absolutely amazing stuff with these 3D maps. We had one project in a previous company where we were hired to count all the trees in Switzerland. That was kind of cool. They wanted they actually in Switzerland keep track of the trees individually. So they know if somebody cuts down a tree. They're all surveyed and numbered. Yeah, you want to talk about annual government, but that's another story. It's a good job. They've been used extensively here in Houston to study flooding, or here in Houston. This is not Houston. Over there in Houston to study flooding. Because you can make an extremely accurate rendition of the ground plane. You can see where the water is and where the water is going to collect and where it's going to go, particularly in a flat place like Houston, which only has a few places for water to go. I can tell you all sorts of things about your topography